Start with is this. I want us to take a look at the following sequence: log of 5, log of 50, log of 500. What would be the next one if I had to go there? Log of 5,000. But keep going until you kind of see a little bit of a pattern here. Maybe you can kind of make some predictions after a little bit of a while. So log of 5. Now what base logarithm am I necessarily working with? 10. So log of 5 is 0.69897, etc. Then log of 50 what's the pattern that we're kind of getting at here? What's going on? Yeah, when we multiplied by 10, you're really only adding 1 to the logarithm, right? So the next one is 2.69897, etc. So you multiply by 10, but it only adds 1 to the logarithm. And what that suggests is that the logarithm has some strange properties. Now, the properties for the log are related to properties for exponents. There's 3 basic properties, and there's some more that kind of follow from that. But the 3 basic properties that I want you to know are, starting with the product rule. And the product rule for logs really kind of follows from the product rule for exponents. When we're dealing with exponents, if we had, say, 2 things with the same base, when you multiplied their base, what'd you do with their exponents? You add them. So the product turned into a sum. And the same thing's going to happen here. The log, and I'll write base b because it's true for any base, of m times n is the log base b of m plus the log base b of n. You add the logs together. So you can turn a product into a log, or into a sum. In a similar way, there's a quotient rule. And this one gets kind of twisted around a lot. But let's think about what happens when you divide 2 things with the same base. When you divide 2 things with the same base, say again, if we have a to the m divided by a to the n, what happens with their exponents? You subtract them. And I'm going to do the same thing with the logs. So this is going to become the log of the numerator minus the log of the denominator. And I keep on writing base b because these properties of logarithms hold true no matter what the base is. It could be base 10, could be base e, could be base 6, base 2, base 3. Anything as long as b is greater than 1 and different than, or greater than 0 and different than 1. Now there's one last rule that we need to know, and that's our power rule. So power rule is this. When we have log base b of some number to a power, that power can kind of come out in front. I sometimes kind of jokingly call this the parachute rule. I imagine a CEO with this nice parachute clause. He's jumped ship. So he comes out in front and says, oh, okay, I'm out of here. Log base b of m. But that r comes out in front. Now these are your 3 big basic rules. They're going to get a lot of work done for us. Let's go back and see if we can't understand a little bit more of that pattern that I started things out with. And I'm also going to try and reinforce something that we saw in 11.5. Now back up here, 50 I can consider as being 5 times 10. So really what this is saying to me is that this property of log says But I can rewrite this as the log of 5 plus the log of 10. Okay. What base is understood to be here? 10. And now we see something that I kind of highlighted a little bit in the last section. What's the log base 10 of 10 to the first power? Anyone want to guess on that? It's just 1. So this is a 1. So it's basically the log of 5 plus 1. Likewise, the log of 5 times 100 is the log of 5 plus log base 10 of 100. What power of 10 gives you 100? 10 to what power gives you, it's supposed to be 100? 2. Thank you. So again, log base 5 of 2. So every time I multiply by 10, I'm just adding 1 to this number over here. Because you're just increasing the log base 10 of some number by 1. Let's play around with a few more here. And again, get comfortable with our rules. We'll start with problem 34. So the log of xy. Now, have they written a base here? No. So what base is understood to be here? 10. So I'm just going to kind of leave it as being understood. Bless you. So it's just going to be the log of x plus the log of y. Let's try another one like that. Problem number 32. Except this time we've got a base a little bit more interesting. Log base 3 of 27 times 5. So let's see if we can't break that up using the product rule. Abdulaziz, how would I break this up using the product rule? What would it look like? Log base 3 of... It's times. It's not a 0.5, it's times. So it's log base 3 of 27 plus log base 3 of 5. Good. Now there is one more thing that you're going to be asked to do, and that's simplify this one. Minnie?
Is the plus log 3, 5, is that all
3 is a subscript, so that's the base. So it's log base 3 of 5.
Is all of it subscripted up?
Well, the 3 is on one line. Here, let me show it to you from the book. There. So 3 is a subscript. That's written kind of below the line. Everything else is on the line. So it's log base 3 of 27 times 5. It's on page 972. All right, so over here, as far as our first step is concerned, again, the 3...
Log 3 to 5. Is that written at the same level as the log 3, or is it written on the same level as 27?
The only thing that's not on the same level is the 3. The 3s are subscripts. Everything else is on the same level. Okay. Can I simplify this? Log base 3 of 27? What would that be? What power of 3 gives you 27? 3. So the answer that you would see in the book And the answer that I would expect for something like this is 3 plus the log base 3 of 5. Log base 3 of 5, we'll actually learn a formula to calculate that, but right now we'll just leave it as is. All right, so a couple problems to practice with our product rule. Let's practice with our quotient rule next. We'll start with problem number 40. Problem 40 has a natural log. So we've got the ln of 27 divided by 4. Is that right? Divided by e, sorry. ln of 27 divided by e. Now there's no, you can write this as log base e of 27 over e. And there is, at least in this case, a little advantage in doing that. Maybe it'll help you see some simplification. That's going to be the log base e of 27 plus the log base e of e. So maybe I should get in the habit of drawing myself a little line here. All this is on the same line except the base of e. Like the last one, I do get some more simplification. Yeah, thank you. Should be a subtraction. Yeah, because it's a quotient rule. My bad. Like the last one, I do get some simplification. Does anyone see what else I can simplify there? Thank you. That is a 1. What power of e gives me e? Now, there's nothing wrong had you written it as ln of 27 minus ln of e. You could still get the same thing. It's going to be ln of 27 minus 1. But help me out here. Answer me a question if you would. Is it easier to see that this cancels to 1 here, or just to remember it down here? Which one do you like better, the first one or the second one? First one? Is there kind of unanimous on that? Unanimous on that one? Yeah, unanimous on that one. All right. All right. Yeah, I think it's easier to see that. Okay. Yeah, you get that nice cancellation. Nonetheless, you will see this, and you're supposed to remember that that's equal to 1. I tend to write it like that. Next one. Problem number 50. 50's got a little bit of a twist or a trick on it that we want to pay attention to. So let's see what we got going with number 50. Log base 6 of 1 over 36r. Log base 6 of 1 over 36r. Boy, this actually will simplify quite a lot. Let's see here. What's the first step? What can I write first to get going? Perfect. Okay. Someone else. What else can I do? Thanks, Mitchell. Kennedy? Any suggestions? Is there any other rules that apply? Some of those basic rules that we mentioned at the start of this? Simplify this one? This one? Okay. So how does that simplify? What rule can I use there? Anyone? Look back at your notes. What rules can I use? Yeah. What can I do here? Well, this is a product, right? I have something times something else. So I can do log base 6 of 36 plus log base 6 of r. Now if I wrote it like that though, I'd actually be making a mistake. And I'm really sensitive to that because I was caught in a mistake earlier. So I don't want to make another mistake. Exactly. So what's happening is that you're subtracting this. And this expands into this. It's just the product rule. But without the parentheses, if I were to remove the parentheses, that negative has to distribute itself. Log base 6 of 1 minus log base 6 of 36 minus log base 6 of r. So you're free to write it one of two ways, either like this or like this. Either one is fine with me. But there is some more that we can do here. Can anyone simplify either of these quantities? All right, so the second one here is 2. What power of 6 gives me 36? A 2. All right. Try and use that same logic to answer the first one. What's the log base 6 of 1? 0. What power of 6 gives me 1? The 0 power. So that would be a 0. Overall, we end up with 0 minus 2 minus log base 6 of r, or better yet, just minus 2 minus log base 6 of r. Now these properties look strange, and they're going to take some getting used to, some practice, and that's fine. We're going to do a lot of both. The reason we're practicing them now is because in the next section, we're going to spend some time learning how to solve exponential and logarithmic equations, and you have to have these properties down in order to be successful in the next section. Did anyone look ahead at the syllabus? See what we have for this Wednesday? We're covering just 2 sections, right? Section 11.7 and 12.1. Does that suggest anything to you? One of them is kind of hard, all right? And that would be section 11.7. Actually, I don't like to say hard. Let's say challenging. It sounds a little softer, right? So, all right. So make sure you bring your game face for Wednesday and practice these stuff. Let's keep going. Don't get ready to close your books. We got a lot left to do in section 11.6. Let's see. So that was problem number 50. Let's work with our power rule a little bit. Problem 56. So the ln of z to the 9th. Rachel, what would that give me, please? Maybe not 56. 52? 52. Well, what should catch your attention is we've got an exponent. And earlier I said that this thing parachutes out in front. So this would be 9 times log base e of z. And there's really no reason to write it as log base e of z here. I'm just going to write it as 9 ln of z. You could have got the same thing here, 9 ln of z. The point of this one is just to try and get you familiar, comfortable with these exponents, these powers. Let's try a couple more with the power rule, and then some that are kind of all together. Next one would be problem number 54. Log of the cube root of 7. Oh, did I give you the cube root rule for logs? No? Oh, that's because there isn't one. Sorry. So we're going to have to do something else. And that something else is kind of a good reminder. Let me put a little 1 there. It's not really part of the problem, but it is a good reminder. Can anyone rewrite that using exponents? The cube root. Oh, okay, yeah. This is the log of 7 to the 1/3 power. So with these problems that involve radicals, you have to rewrite them using exponents in order to use your rules for logarithms. How's this one finish up then? Thank you. 1/3 log of 7. I can kind of see that, some people might be able to go from here to here. That's fine. But for a problem like number 70, I think we might need to see some work. In fact, we should probably do some work in problem number 70. But let's take a look at, why don't you try number 58 first. So number 58, log base 3 of the, what is it, the square root of 10 to the 5th? Let me just double check. Yeah. Yeah, square root of 10 to the 5th. So you have to be a little bit more careful working with the exponents here. Colin, what's the square root of 10? How can I rewrite that? Square root of 10 is 10 to what power? No? Some help? Yeah, something, the square root of something is something to the 1/2 power. You could think of this as being a 2 here and a 1 here. The 1 comes up, the 2 comes over. This is something to the 1/2 power. What I would suggest is that before we start using our rules for logarithms, let's finish using the rules for exponents. What happens with these exponents when I remove the parentheses? Do they add, subtract, multiply, or divide? Multiply. So that's going to be 10 to the 5/2. Lauren, we've cleaned this up a little bit. Can you do the last step? So the 5/2 comes out in front. 5/2 times the log base 3 of 10. Let's try problem number 64. Log of x, y squared, z cubed. It must be mind-numbing to write a textbook and to have to come up with problems again and again and again. And you can see that the author was kind of like getting tired here. It was a x, y, z, 1, 2, 3. All right, but it's still a problem that we're going to work on. Now, the first thing I'll notice for you is that we've got a product here. What happened when we took the log of a product? How did we split that up? Turned it into log of a product, turned it into a sum. Now, can I bring the 2 and the 3 out here? No. And the answer is no, because that 2 only applies to the y and the 3 only applies to the z. So the first thing I'll do is I'll write log of x plus the log of y squared plus the log of z cubed. And this is an important property to notice, that when you have the log of a product, it turns into the sum of the logs. I didn't do this kind of piecemeal. I just jumped to that conclusion right away. I could show you piecemeal, but let's just do it this way. Am I done with this one, though? Is there anything else I can do with my favorite 3 properties of logs? Let's just start getting used to this little pink pen here, right? These little parachute things keep coming out in front. So you end up with a log of x plus 2 times the log of y plus 3 times the log of z. On an exam, what you would see, what I'll write is expand the logarithm using the properties of logs, something like that. But what you're doing is you're expanding it, expand the log. So now expand the log is not to be confused with expanding the log this way. That's kind of a more literal interpretation of expand the log. All right, I'm not going to give you credit for that one. It's cute. You might get a little ha-ha, but all right, expand the log means this. Feel free to laugh. All right, good job. Let's try problem number 70. ln of the square root of xy. There's a couple ways you can do this. Now, even though this is ln, our properties of logs still apply here. They're still the same. You still have the product rule, the quotient rule, and the power rule. Regardless of whether or not you write this as log base e or ln, what should be our first thing that we do here? How should I rewrite this? Don't make Mitchell do all the work here this morning. Someone else. All right, perfect. ln of xy to the 1/2. Now, do I need the parentheses or no? If I wrote it without parentheses, would that be correct? Yeah. Here, it's only going to the y. Here, it's going to both of these. So I definitely need the parentheses. Now, there's a couple choices here, but I would suggest that we take the 1/2, bring it out front, 1/2 ln of xy. What rule do I use next here? Would I be correct in writing it like this? This is something you're going to have to get careful with. Yes. Perfect. So again, let me expand this way. That 1/2 has to multiply both terms. So I'll give you 2 options. You could either write it like this, or you could distribute the 1/2 to both terms. But either write it with brackets / parentheses or distribute it to both terms. But if you just wrote it like I had originally, you're going to lose a point. It's very easy to do. I always try and be very careful when we go over this stuff to explain that. Yeah, no, so there is another possibility here, and it's going to lead to the same conclusion. What if I said, you know what, this is really ln of x to the 1/2 and y to the 1/2, like that. Okay. Log of a product is the sum of the logs. That's log of x to the 1/2 plus log of y to the 1/2. But then those exponents come out in front and you get the same thing. So yeah, there's a lot of different ways you can work your problems with logs. And when I grade these, I just kind of have to look at, what you did. So definitely I don't have, a patent or copyright on what the right way is for these types of problems. There is no one right way. Yeah, as long as, you do end up with the right answer. There's a lot of different ways you could work that one. Yeah, and then I think, Mitchell, you said that you actually did the same thing I did, except with the square roots. And that's fine. It's fine. It works the same thing. All right, let's go backwards. Now, going backwards, it's again just practicing these same rules so that when we get to section 11.7, you're comfortable. We're going to add these things together. Or because we're adding these things together, I can think of that as a product. And then I can write that like this. And I can write it like this. What we're going to work towards is writing a sum or difference of logarithms as the log of one term. So the actual instructions for something like this say write each logarithmic expression as one logarithm. So you want to start out with something like this and end up with something like this. We'll begin that with problem number 76. Two log of x plus 1/2 log of y. All right. I can't use my product rules in kind of the reverse direction just yet. In order to use the product rule, which is this, log of a plus log of b equals log of a times b, what we've done up till now is we've used it this direction. Now I want to use it this direction. There's one requirement though. The coefficient of each of those logarithmic terms has to be a 1. In order to use your product rule and change this into the log of the product, you have to have a 1 here. So what could I do here to make these a 1? Well, let's bring these up into the exponent. You're going to use your power rule in the opposite direction. So this will become log of x squared plus log of y to the 1/2. Well, that's better. Now I can use this rule right here. The sum of the logs becomes the log of the product. Log of x squared y to the 1/2 like that. Let's try another one kind of like that. Problem number 78. Minus 2 log base, or just log of x, minus 3 log of y, plus log of z. Okay, so there's a lot of ways to do these problems, but for this one and ones kind of similar to it, let me suggest we start out doing exactly the same thing we did with problem number 76, except we're not just going to put the 2 up into the exponent, we're going to put the negative there as well. So this becomes the log of x to the negative second plus the log of y to the negative third plus the log of z. So, again, you could just play around by taking the 2 and the 3 up there, but I find it much, much more efficient if you take that negative with it. Now, here comes the important part. Let's squish all this together. How does that all come together? Log of what? X to the negative second, y to the negative third, and z. Perfect. So again, and this is important. The sum of the logs becomes the log of the product. We'll practice that with a specific example in just a minute. There's one last thing that I would ask, and that is, let's get rid of the negative exponents. How could I get rid of the negative exponents? Yeah. In fact, kind of the shortcut there is to just put those into the denominator. So x squared y to the third, both in the denominator. And that's how I'd like your answer, and that's how you're going to see the answer in the book, is written without the negative exponents. This is the safest, most efficient way to do these problems. So if you have those negatives, just take them up there into the exponents. You can play around with the quotient rule. That's fine. We'll do an example with the quotient rule. But for now, I'd strongly suggest you do it like that. Let me give you another one to practice this idea right here, that the sum of the logs becomes the log of the product. So this one's not one that's in the book. So what I'm going to want you to write, what I want you to do is rewrite this using one logarithmic term. And ready, set, go. All right, so a stamp of intellectual nobility for the first one to laugh. Good job. The rest of you feel free, anytime the mood strikes you, laugh outrageously loud. Yeah, that was brilliant.
I do have a question.
Yeah.
The last one that we worked on, when you said play around with the quotient rule, you meant rewrite it and then say because it was subtraction, you can put them in the denominator?
Yeah.
Oh, okay.
Yeah. It's there's probably easily a couple dozen different ways you could do that last one. But what people get messed up on is what's positive, what's negative, quotient, etc. And then they make a mistake using the quotient rule. So, come on. I had to wait all semester for this one, and all I get was a aha. Come on, give me some love. All right, yeah, you smiled. All right, Colin, come on, man. All right, there we go. Grudging acceptance. All right. Okay. So, yeah, I'll keep my day job. Okay. All right. Oh, if I had feelings, they'd be hurt. Okay. A couple more to finish. And his jokes are as bad as mine, right?
Yes.
Okay. See, we all have to go through a 3-credit course in bad puns. So. Sadistics, yeah. So if a statistician has his head in the oven and his feet in the freezer on average, he feels fine. So. Okay. Problem number 82. So 1/4 log base, is that A? Yeah. Log base R. You know what? I'm just going to ignore that. Log. There you go. Log of n squared minus 16 minus log of n minus 4. And a closed bracket like that. Let's not distribute the 1/4. Let's work with inside the parentheses, because working with inside the parentheses, our coefficients here are already 1 and -1. Now, because I've got a log of something minus a log of something else, I don't have any coefficients, let me use my quotient rule for this. This is going to be the log of n squared minus 16, that's our numerator, over n minus 4 is the denominator. What it's not equal to, and I understand there's a huge temptation to do this, you can't write it as the log of this divided by the log of this. It's just not the case. I understand where this desire comes from, but it's wrong. There's a few more things we can and should do here. Can I cancel the n and the 4 into the 16? No. Not, at least not right now. But how does this thing factor? Thank you. N plus 4, n minus 4, and there's a couple of you that volunteered on that. Thank you. Now can I cancel? Absolutely. Those cancel. So we're getting some nice work done without having to worry about this thing yet. But finally, let's get rid of this. How can I get rid of the 1/4 out in front? Gil? What do you suppose I can do there? Sure. All right. Now, in my book, they don't write it with an exponent, they write it with a radical. So, Rachel, what radical would go with this? Remember our little boot method? 4 comes over, the 1 drops down. It's going to be what root? 4th root of n plus 4 to the first power. Now you don't need brackets to the first power there. You could just write, log of the 4th root of n plus 4. That's fine. I'd probably accept something like this unless I gave specific instructions to write it, using a radical. That's fine. I would like to see the simplification here. That's something that I would expect, is that you factor it, cancel, and then solve. In light of that one, let's take a look at problem number 104 and 106. So problem number 104, kind of a good one. You've got A is this expression, log base 6 of 7/9. B is this expression, log base 6 of 7 over log base 6 of 9. And C is this expression, log base 6 of 7 minus a log base 6 of 9. The question is, which of these are equivalent? Which of them effectively mean the same thing? And we'll do the same thing for part problem number 106. Part A is the ln of the square root of t. Part B is the square root of the ln of t. And part C is 1/2 ln of t. So try and figure out which ones of those are equivalent. I'll walk around and try and help out. Help each other out too. So what's equivalent to A in problem number 104? C. Just applying your quotient rule. This is not the quotient rule. How about for 106? What's equivalent there? Yeah, C again. If you were to have to explain your reasoning, you'd say, all right, well, that's the ln of t to the 1/2, and then you can use your power rule there. So kind of a different spin on some problems there, kind of a few lookalikes. I get those things, I see those things confused for people a lot. So there'll be a couple problems in the homework from that section. You should look at that up. You should check that out. Now, one of the things that you run into, even today, is the need to calculate the logs of various bases. Right now, on the face of your calculator, all we've got is log base 10 of x. And what's the other one that's built into our calculator? What other base? Yeah, we've got log base 10 and log base e. Those are the things that are on your calculator. But earlier we dealt with log base 6 of something. Log base 6 of 36. How do you calculate things when you don't have that on your calculator? There's what's called a change of base formula. So, if you're nice and laugh at my jokes the rest of the way, maybe I'll just give you the change of base formula on your exam, okay? Ready? Practice. Go. All right. All right, pretty good. So the change of base formula looks like this. And I'm just going to give you the version that's most practical. Log base b of x is the log of x divided by the log of b. So if b is some number for which you don't have it programmed directly in your calculator, you can calculate the log of that by taking the log of this divided by the log of the base. Let's try it with one that works out nice and simple. So for instance, if I add log base 6 of, we'll do 36. We had that one earlier. That'd be the log of 36 divided by the log of 6. Now don't mix this up with your quotient rule in any way. And when you type that into your calculator, you're going to need to be careful. So, let me show you two different ways to do this on your calculator. The first one is kind of like the brute force approach. Log of 36, right parenthesis, make sure you close off that log, divided by log of 6. And I should get 2, of course, because 6 to the second power is 36. If your calculator is up to date, hit the alpha key, then the Y key, and just type it in as a nice fraction that way. Log of 36 divided by log of 6. Should give you the same thing, but people get in a little bit less trouble with that as opposed to trying to type it in the first way. So let's try a couple problems where the numbers don't work out quite so nice and even. And that would be a problem like number 96 and then 98. So number 96 is a log base 7 of 3. So basically you're asking yourself, what power of 7 is going to give me 3? Well, I don't know. Couldn't even guess. The most I can do would be guess that it's less than 1. Because 7 to the first power is 7. So it has to be something less than 1. Now, in terms of entering that into your calculator, that'd be the log of something divided by the log of something else. What do I get on that one? Mackenzie? Log of what over log of what? Log of 3 over log of 7. Log of 3 divided by log of 7. I'm getting 0.5645, etc. Are you guys able to get the same thing? Camila? Yeah? Good. Thank you. How could I check it? If I was like, I'm not really sure about this. How could I check this? Any suggestions? Perfect. 7 to this power should be 3. And guess what? What do you have right here? You've got that power. So if you hit 7 and then the power key right up here, so raised to the power of my previous answer, second, and then the minus key, 3. I said minus key. I should have said the opposite key. So you can check these things. Yeah, I would probably tell you to round it to the 4th decimal place. In this case, that would be, so ... means it continues. This little squiggly line means it's approximately. So this is approximately equal to 0.5646, rounded to the nearest 4th decimal place. Typically on a problem like this, I would tell you, round it to the 4th decimal place or whatever. Sometimes I'll do 3rd, but. Problem number 98. Log base 1/2 of 6. This should be a strange one. I'm guessing a negative number. For your convenience, you can type in 1/2 as just 0.5. You don't have to type in 1 divided by 2. So log of 6 divided by log of 1/2 divided by log of 0.5. Negative 2.5849, 6, etc. Ooh, here's a good one. Let's round this to the nearest 10,000th. Ooh. Let's see what that one's going to look like. What have I picked on in a while? Rachel. What would this be rounded to the nearest 10,000, please? Perfect. If you add 1 here, you get a little change of digit, a little carryover. Negative 2.5850. Let's finish this up with a few problems from the range of problems 22 through 30. And I'm going to add a couple more things to our list of properties for logs. There's a couple more things that we can put here in this initial list. And we've seen this one a couple times. Log base b of b to some power. We've practiced this one a couple times a day. If the base here and the base here are the same, these operations cancel each other out. Can anyone tell me what I'm going to get? X. How about this one? Log base b of just b. 1. How about log base b of 1? What power of b gives you 1? 0. There you go. So those are 3 more. They're not necessarily formal properties. I don't have a name for these things, but they're handy if you recognize these things, especially this one. That these cancel each other out, that's perfect. We will use that. There's one that goes along with this. The reason that these cancel each other out is because you've got a function and its inverse. you add 6 and subtract 6. You square and then you take the square root. They're canceling each other out. And in the same way, I could start out with the b to some power and then do the log. So b to the log base b of x is also x. Again, these cancel each other out. So a few extra rules here. You want to memorize them? It's not bad. I don't like to make you memorize things just cause, but it's helpful to have these things in mind. And with those in mind, let's finish up a few problems and then clear out of here. First one would be number 20. So let me see if I can't keep this straight. So the log base 9 of 9. Problem number 22 is the ln of e to the 8th. Problem 24 is 8 to the log base 8 of 10. Problem 26, kind of the opposite with the same effect. Log base 4 of 4 squared. Problem 28, log base 7 of 1. And last but not least, problem number 30, 5 to the log base 5 of 8. Tell you what, let me give you some homework here. And when you give me the answers to those, we can be done. How about that for a nice carrot and stick approach? I'm going to be kind of picky about the homework, but there's still going to be a fair amount. Fortunately, you only have 2 sections worth today. Homework 19 through 25, 31, 33, and let's skip up to 39, through 45. 51 and 53. 59 through 65. Don't skip these. You'll definitely have problems on an exam coming from that set of the homework. 75 through 79. Same thing. There's going to be some that I'm going to ask you to rework in the opposite direction. 95, 97, 103, and 105. So it actually sounds like a lot, but I've assigned less than a quarter of the problems that I could have assigned. There's 126 problems, you have a lot less than that. Okay, so give me some answers on this, and then we can be done. Or you can be done. Yeah. Individually. 2 steps, what you could have done in 1 step. So if you take a look at this one here,
Okay.
those 2 operations cancel each other out. You could have just gone to that right away. But that's okay, because really what you're doing is you're justifying it. Because 4 to the first power is 4.
Right.
So log base 4 of 4 is 1, 2 times 1 is 2. So that's fine. Cool. Alright, cool. You should simplify that one.
Okay.
That one doesn't look right. That one simplifies. That one's wrong. Alright, so these properties are the ones you need to use to simplify those things. Those will help you out the most here. Okay, ln of e to be simplified. That one's good. That one's good. That one's good. That's good. Ln of e needs to be simplified. Let's see if we can't figure out. It might help you out to write it as log base e. So, this one needs some log. The rest are okay. How about that one? I'd start by writing, well, you changed it. When you wrote it as log base e, it should still be of e to the 8th power. And then simplify it from there. Ln of e to be simplified a little bit. You might want to start by writing that as log base e of e, or log base e of e to the 8th. But the rest of them are. There you go. Yeah, perfect.
I just have a quick question for the test. I don't know if you have a equation around here now.
I don't.
I'm trying to think it was for the one where it was f divided by g. The numerator, yeah, the numerator was 2x minus 5. So wouldn't it be?
No, the denominator is 2x minus 5. The numerator is x squared plus 1.
Okay. That makes sense then.
Okay. Yeah, yeah. No, I mean, as long as you understand. Log base e of e to the 8th. Okay, yours looked a little different. E to the 8th or something like that. And that e is kind of like a subscript.
Oh,
So, I mean,
yeah.
I'm not trying to give you a hard time or anything like that. It's just, I don't want you to get confused. I don't want me to get confused. Okay. That's the right answer. I'm not sure I like that middle step because log base 5 of 5 is 1. This cancels into 8 because of these rules. This rule right here. So you can go from here. So you can go from this to just that. That's all you have to do. So you shouldn't have that middle step there. But you see though how this lines up? We've got 5 in log base 5 of 8. Oh wait. Here we go. Sorry. 5 to the log base 5 of 8. So b to the log is b x. You just get the exponent. So, alright. Okay. That's fine. Well, hopefully you see what you could have done. What power of 9 gives you 9? First power.
Yeah.
Okay. Now, this one, it's this pattern. Where these 2 things match.
Oh, okay.
So if those 2 things match, then
Then
it's
they
just going to
cancel out.
cancel So you don't necessarily want to do this, change it. It worked, you get the right answer. But it's a lot shorter to go, oh, okay, these two match. Ooh, just give me the exponent, because that's really what's going to happen for those types of problems. It's right here. Okay, so I guess I've got to finish the narration on this. Everyone's gone. What power of 9 gives you 9? The first power. The second one might be helpful if you write it as log base e of e to the 8th. And these powers, these bases are the same, so they cancel each other out. You get an 8. And then the next one down. Again, you've got the bases being the same. So this is kind of like this one, right? B to the log base b of x cancels x. Well, instead of an x and a b, I've got 8 and 10. The bottom line is that you get a 10 here. Okay? How about this next one? Problem number 26. Log base 4 of 4 squared. That's back up here, right? So what are we going to get for this one? 2. Thank you. What power of 7 gives me 1? 0. And 5 to the log base 5 of 8. 8. Yeah, again, those cancel each other out. Hey, thank you both.